So what are textures, right? Textures are essentially two-dimensional arrays of pixels, right? And they're stored as red, green, and blue data with a corresponding alpha channel in a number of different file extensions, right? This is an example, sorry, of a texture here. It's just a brick wall texture that I pulled off of public domain textures. And what we can see here is that it's actually made up of these little tiny pixels, and there's a lot of them. All right, there's 512 multiplied by 512 pixels in this image. So this image we would just say is a 512 by 512. That's what we call it in terms of size, right? And even though this looks like a brick wall, right? This looks like a photograph of a brick wall. It's actually not a photograph, right? As far as we're concerned, it's not just a digital photograph. It is three channels. It's a collection of data, which is red, data, which is green, and data, which is blue, right? And when you add the sort of the right ratios of red, green, and blue together, when they mix together, sort of just like colors do, like paints, you get meaningful color, you get meaningful information, right? And in the case of a brick wall photograph, it will look like a photograph, right? But if we look up here into the top left, we can see that I've mucked with the image a little bit, right? So I have erased out the top left corner by virtue of painting it black in the red channel. Black means no influence. There's no red data here at all, and white is full influence. So these are fully red pixels up here, right? And you can kind of see up here how it's pure red. Same thing for green, right? Same sort of pattern down here. I've painted a little bit of green, and same thing for blue, right? Painted some blue. Now what you may notice is that in the areas where all these overlap, in this sort of central area here, right, they sum up to white. They go all the way up to white, right? And I'll just kind of show you what that looks like here. So if I paint white here, and then if I paint white here on the green channel, and we have a look at that, you get yellow, right? Because red and green add together to get yellow, right? If we paint blue, and then we paint some red, we get like a purple, like a magenta sort of thing, right? And only when you add in all of them will it sum toward white, right? So keep that in mind. Now the pixels, the color range in a common texture it's always 0 to 1, right? It's always black to white. And you're going to get 255 values. That's just sort of the way that most images are represented, right? So in the red channel, it's black to white, but there'll be 255 discrete individual colors on that range from 0 to 1, right? Same thing for all of the three other channels, okay? All the other two channels, sorry. Now there is a fourth and sort of final channel, it's a little sort of hidden channel here called the alpha channel, right? So the image has red, green, blue, and alpha. Now alpha determines whether or not the pixels will be visible sort of in game, right? So if we were to texture like a grass blade for a video game, we would paint something like this into the alpha channel, right? And that would basically mean that anything that's black is going to be invisible and anything that's white will be visible. And that is going to depend on the actual shaders that we use and how it's implemented in Engine, but in general think of it that way, right? That in the alpha channel, data that's white is visible and data that's black is not visible. Now I want to talk briefly about file sizes, right? And when I say file size, I really should say file dimensions, image dimensions, right? Or texture size, they'll often say. This one that I've created here is 512 by 512 pixels. You're going to see numbers like that come up quite often because they're powers of 2. They're natural powers of 2, right? And I want all of your images to be powers of 2. So that's 2, 4, 8, 16, 32, 64, 128, 256, 512, and then, it keeps going up. 1024, 2048, 4096, 8192, right? The reason that we want to do this is we always going to want to keep them power of 2 because that's how all of the graphics cards are configured in hardware. It's how all of the rendering hardware has been for decades. Your textures are made to be this size, or they will eventually be made to be this size, right? So always stick to power of 2, and when in doubt, stick to square. Now, it doesn't always need to be square. You can have mismatching aspect ratios, right? We can have a width of 1024 and a height of 2048, or even a width of 512, or we'll say 256 and a height of 1024, something like that, right? So this is a very rectangular image, but you'll see that it's still a power of 2 image, right? We're still sticking to that power of 2 convention, okay? if you don't stick to this power of 2 convention, like let's say you were to make this image size, say 960 pixels high, right? Your graphics card is going to scale this back up to 1024 anyway, right? So you basically just have a carte blanche to always use power of 2 size textures. Prefer square, but you don't always need to prefer square. Rectangular is fine, okay? Now I want to talk about file types, right? So when we create our images, they will be saved and manipulated as actual files on disk, right? They won't be meshes, they won't be like meshes that live in Blender, right? Where we're editing them and manipulating them in Blender. Even if we manipulate them within Blender, they still live on the hard drive, right? Almost always they live on the hard drive as an individual file. And these files have different strengths and weaknesses, right? So I just want to talk about 2 in particular. We've got .jpeg, JPG, right? And we've got .png. Now, JPEG used to be the most common format, really, but now PNG really is sort of the most common format. And it's because of these 2 features here, right? The JPEG is compressed, lossy. It has lossy compression, which means that when you save it, some of the data that you write into that texture is permanently destroyed. And that allows it to have an incredibly small file on disk, which is great for sharing images around the internet, but not super great when we're trying to make art for video games, right? And our players want to experience sort of the best quality like textures we can give them, okay? So PNG, however, basically doesn't lose any data when saving. It has lossless compression. So it can still compress. It can still be pretty small on disk, not as small as JPEG, but in exchange for not losing any data when saving, right? We also talked about the alpha channel before, that little 4th channel that gives us sort of invisibility. JPEGs don't tend to support that, right? Whereas PNGs do, they readily support it. And so due to the comparison between these 2, PNG tends to just sort of be the most common format, right? Because it seems to really have a lot of strengths and very little downsides, especially when compared to JPEG, right? It does have some downsides, but you know, in general, it's completely fine. So you're pretty much always going to stick to PNG, right? There are other image formats, and you've probably seen a bunch of these as well, but you've got bitmaps, right, which are quite literally just the bits of the image themselves stored uncompressed, so they're actually quite big and more like a historical format. We've also got TGAs, which I think is short for Targa, and they come in 2 variants. They come in 24-bit and 32-bit, right? Now, just like up here, how our JPEG has no alpha support, and our PNG does have alpha support, the 24-bit version of Targa doesn't, and the 32-bit of Targa does, right? And they're quite a bit more chunky, like on disk. They're a bit bigger, right? But I commonly, and a lot of other people do as well, will use 32-bit Targas to solve like PNG's weaknesses that you'll get into specifically a little bit later, right? There's also TIFF, EXR, and I wanted to include PSDs here, okay? TIFFs, I don't, you know, they do some interesting things, like they have some sort of layer support internally, not really used all that much. EXRs are typically, they store data that is above 1, right? We talked about in our image channels, we have that sort of 0 to 1 range, right? That black to white range with those 255 discrete values. EXR can go much higher than that. So you'll typically see EXR maybe used in photography and like lighting and skyboxes and like, you know, these sorts of things. Now, PSD stands for Photoshop document. It's not really an image file, it's not a true image file, but because of Photoshop's prevalence globally, there is actually a lot of support for importing PSDs directly into your engine. So these actually can be sometimes decent to use, but most of the time not. People will almost always sort of push you away from using PSDs. So in general, stick with PNGs, right? That's how we're going to go in just the beginner stuff. There's edge cases where you don't want PNGs, but it's a pretty good file format all up, right? The reason I'm confident in saying that just stick to PNGs is because of this little note down here, right? None of these images will eventually make it to the actual PlayStation or the Xbox, right? Or the PC game that we're actually making, because they all get compiled into a different format. The final format that ends up getting rendered, that will commonly be .dds on Xbox and PC, and I think we've got, I think BC1, no, I can't recall, but either way, PlayStation has its own specific file formats. Apple has its own specific file formats, and so the long and the short of it is all of these images will get compiled and converted into the platform specific images, right? So that's kind of why I state this rule here. Feel free to pick whichever image format works for you, right? Works for you in the context that you're using it, because the game engines are eventually just going to convert them into a different file format anyway, okay? I was kind of struggling to come up with the names of them before, but I'll have a more advanced chapter later where I sort of, go into more advanced texture specifics, and we'll talk about all of those there, okay?